My dear friends, welcome back to BSpice. In this session, we'll focus on IEC 61850. So this is more of a concept wherein we'll dive deep into the key features, the major benefits. Okay. Uh, in fact, I decided to upload this because I'm going to give you some videos on, smart grid application later on. So that's why I thought it's appropriate to, upload this concept. Okay. Right. So yes, one of the, friends, significant challenges that substation engineers face is justifying the substation automation investment. Okay. You know, the legacy communication protocol were typically developed with the dual objective of providing the necessary function required by electric power system while minimizing the number of bytes that were used by the protocol because of several bandwidth limitation. Okay. So later, Ethernet and modern networking protocol like TCP/IP become widespread. So these legacy protocol were adopted to run over the TCP/IP Ethernet. So by doing this, it provides the same, basic electric power system capabilities. Okay, while bringing the modern, advantages of the modern networking technologies. But this approach has a fundamental flaw. Flaw in the sense the protocol being used was still designed to minimize the bytes on the wire. So that is taken care. But we do not take the advantage of the vast increase in the bandwidth that modern technologies can deliver. So that is the pointer. So here, this IEC can, support in providing a higher level of functionality by the modern networking technology, and thereby significantly reduce the implementation and operational cost of substation automation. So in this session, we are going to dive deep into those, how this is going to help in achieving the operational and implementation cost reduction. Okay, let's go. Modern technologies. IEC 61850 is unique actually. IEC 61850 is not like a former serial link protocol recast onto TCP/IP, okay, Ethernet. So IEC 61850 was designed from the ground up to operate over modern technologies and delivers an unprecedented amount of functionality that is simply not available from legacy communication. Okay, so let's see the key features here. Key features in the sensor, it actually has many features. For example, the use of VLAN, virtual LAN, and priority flag for Goose SMV enable much more intelligent use of Ethernet switches. So you may have a question here. What is Goose? All this, right? So Goose is nothing but the generic object-oriented substation event. It's a communication protocol defined by IEC 61850 standard. So basically, it's designed for fast and reliable data exchange between intelligent devices, intelligent electronic devices, IEDs, right? In electrical substation. So that's about this. And of course, I'm going to dive deep that in the later section. So let us go into the features first. So one of the feature is the use of virtualized model. Okay. So basically the virtualized model of logical device, the logical nodes, ASCII, all these actually enables definition of the data, services, and behavior of devices to be defined in addition to the protocols that are used to define how the data is transmitted over the network. So basically all the, devices are virtually modeled actually here in this IEC 61850. Then use of names. Every element of IEC 61850 data is named using descriptive strings to describe the data. Legacy protocol on the other hand, they identify data by storage location using index number, register number, all these. But here we are using descriptive strings. That is very easy, right? Then all object names are standardized and defined in the power system context itself, meaning The names of the data on the IEC 61850 device are not dictated by any device vendor or configured by the user. All names are defined in the standard itself and provided in the power system context. Okay. Thereby enables the engineer to immediately identify the meaning of the data without having to define mapping, all these. Okay. Then the devices are self-describing. Client applications that communicate with the IEC 61850 devices are able to download the description of all data supported by the device from the device without any manual configuration. So basically, these are self-describing. Then high-level services. So as I highlighted earlier, it supports variety of services. Like GOOS, GSSE, SMB, just few unique capabilities. So again, we'll talk about GOOS here. Okay, GOOS is nothing but a generic object-oriented substation event defined a communication protocol defined by IEC 61850 standard. So it is designed for fast and reliable data exchange between electronic devices, IEDs, in substation. Okay. See, just imagine, friends, high-speed communication. See, boost messages are transmitted within 4 milliseconds. Just imagine, 4 milliseconds, making them suitable for time-critical application like protection and control. Okay. And also it uses publishers subscriber mechanism, okay, where messages are broadcast to multiple devices simultaneously. And also event driven. So it's all the messages are triggered by events such as changes in the status of a circuit breaker. Okay, right. Then of course very reliable, yes, and vendor dependent. So that is the beauty of this GOOS. Then also I touched upon GSSE, right? GSSE is nothing but the generic substation state event. It is also a communication protocol defined in IEC 61850, similar to GOOS, but some key differences. Here, status data exchange. It is basically designed for exchanging status data using a status list, actually. A list in the sense a string of bits rather than a data set like GOOS. So in the GOOS, it's a data set, but here is a string of bits. And also, it also helps for event transfer mechanism, all these actually, okay? Then what I talked about SMB, right? Yeah, SMB is nothing but a sample measured value. This is another key communication protocol defined in IEC 61850 standard. Again, this is used for the real-time data transmission, high precision, and internet-based communication, all this. Yes, this is about the high-level services. And we also have a standardized, standardized configuration language. So basically, this we call it as SCL. This standardized configuration language SCL enables the configuration of device and its role in the power system to be precisely defined using an XML file. That is the beauty of this. Okay. It provides standardized format for describing the configuration, okay, of substation device, ensuring the interoperability between devices from different manufacturers. Okay. Right. So that's about this, friends. Key features. Okay. Then we'll talk about the major benefits here. Okay. So of course, many benefits are there. Let's see one by one. Eliminate procurement ambiguity. Okay. Not only this SCL can be used to configure devices and power system. SCL can also be used to precisely define user requirement for substation and devices. For example, using SCL, a user can specify exactly what is expected to be provided in each device. That is not subject to misinterpretation by suppliers. Okay, it's very clear. So it eliminates the procurement ambiguity. Okay, then lower installation cost. IEC 61850 enables devices to quickly exchange data and status using GOOS and GSSE over standard LAN, station LAN, without having to buy a separate links for each relay. So that is the beauty. So this significantly reduces the wiring cost by utilizing the station LAN bandwidth for this signal, and construction cost by reducing the need for, trench, DAGs, conduit, etc. I think it is repeating. Okay. So the next is a lower transducer cost. Rather than requiring a separate transducer for each device, a single merging unit supporting SMV can deliver this signal to many devices using a single transducer, thereby lowering the transducer wiring and maintenance and calibration cost. Then we have a commissioning cost. The cost to configure and commission devices is drastically reduced because IEC 61850 device don't require as much manual configuration, which is needed for the legacy. So here we don't have to do any manual work. That is the beauty. Okay. Then we have a lower migration cost. Because IEC 61850 defines more of an externally visible aspect of devices, besides just the encoding of the data on the wire, the cost of migration is minimized. That is also another point. All devices share the same naming convention, minimizing the new configuration. All these. So thereby we also reduce the migration cost. Then not only migration, it also reduces the extension cost. Because IEC 61850 don't have to be configured to expose data, new extensions are easily added to the substation without having to reconfigure device. Okay, so that is about the lower extension cost and of course integration cost also. By placing the same networking technology that is being widely used across the utility enterprise, the cost to integrate substation data into the enterprise is substantially reduced. So that is about the lower integration cost. And of course, we have implemented new capabilities. The advanced services and unique features of IEC 61850 enables new capability that are simply not possible with a legacy system. Okay. So that's it, friends, about this new major benefits actually, right? So now we'll go into the overview of IEC 61850. So overview in the sense, this was published for the first time in 2004 actually. After that, it has gained more and more relevance in the field of substation automation. So yeah, it provides actually effective response to the need of the open, deregulated energy market, which requires both reliable network and extremely flexible technology. Okay, so flexible enough to adapt to the substation challenges. So IEC 61850 has not only taken over the drive of the communication technology, okay, of the office networking sector, but it also adapted the best possible protocol and configuration, for high functionality and reliable data transmission. Then industrial Ethernet, which has been hardened for substation purpose and provides a speed of 100 megabit per second, offers bandwidth enough to ensure a reliable information exchange between IEDs, intelligent electronic devices, to a substation controller. Okay. Then what else? And yeah, it is just more than just a protocol, friends. IEC 61850 also provide benefits in areas of engineering and maintenance, especially with respect to combining devices from different vendors. Okay, so that's about this. Then object-oriented. An object-oriented and application-specific data model focused on substation automation using this IEC 61850. Okay. Then what is peer-to-peer communication also? Peer-to-peer communication for fast data exchange between feeder-level devices, that is the protection devices and bay controller, is supported by GOOS, that is generic object-oriented substation event. Okay. Then we have a SCL, which we already talked actually. What is that? SCL is a substation configuration language. Okay. So that is one of the features, a crucial component of this IEC standard, 61850 standard, designed to facilitate the configuration of integration of substation devices. So that is the beauty. Yes, then what else? I think that's all on the overview. Yes. So that's all, friends. Just want to, give you the benefits, the features of IEC 61850, how we can, reduce the cost, all this. Hope you had a very good session. Thanks for watching and keep supporting friends. See you in the next interesting video wherein we talk about the, smart grid and the SCADA as a distribution management system. All these are coming up. Thank you and take care. Bye-bye.